Hey, welcome back. So we're going to take a look at a couple more examples of double integrals. But in this example, we're going to take a look at what happens if we are taking a limit to infinity. Now, the first thing to remember, this is improper. So if it's an improper integral, means we must write as a limit. So let's take a look and see if we can remember how to do this. All right, so for the first one, we're going to look at this inside, the derivative in terms of x. And notice we're doing dx and dy. So if I look at this one, this is going to become the limit. Now remember, this is my improper part, so I'm going to call that b. As b goes to infinity of the integral 1 over xy from 1 to b dx. We saw this last year. Now I'm going to integrate this with respect to x, which means my 1 over y is a constant, so I can actually kind of factor that out. And I can write this as 1 over b, 1 over x dx. And of course the antiderivative of 1 over x is just natural log. So we get 1 over y times the limit as b goes to infinity of the natural log of x. And when you evaluate that from 1 to b. So what do we get? Let's see if we can do this. 1 over y times. Well, if I let b go to infinity here, we should be able to do this. This becomes natural log of b, which goes to infinity. That just becomes infinity. Minus, and if I plug in this 1, the natural log of 1 is just 0. So what do we get? Well, we're just going to get infinity in this case. Wow. So we're just getting infinity. That's kind of weird, because now we got to integrate infinity with respect to y. So we really can't do this, but let's just kind of see this. So if I try to investigate the area of infinity to 1 to infinity of dy, well, of course that's just going to become infinity as well. So therefore we say that this diverges. It doesn't become anything right there. We can't integrate infinity. So we really can't even say that, so we can probably just answer from right over there. It's just going to diverge in that case. All right, let's take a look at a couple more examples here graphically. All right, so we want to, for this one right here, we want to set up a double integral. Now this is a rectangle, so remember, so down here it's going to give me my change in my x's, and of course over here this is my change in my y's. Well, we know to get area it's going to be change in x times change in y, or if you want to switch it around, you can do change in y times change in x. So to find the area underneath this graph right here, we have to find our limits. Well, what is the change in x? Well, x is going to go from 1 to 2. And let's see, my change in my y values? Well, my y values go from 1 to 3. So if I want to write the area of this equation right here, well, what would we do? Well, I know area is delta x times delta y. Or you could switch them around if you like to, but we're going to let these go to 0. If we let these go to 0, remember we're going to get dx dy, and that's going to give us an infinitely tiny little rectangles, and we're just going to add up all those infinitely tiny little rectangles. The first one, we're going to add up all the ones dealing only with the x's. Well, my domain there goes from 1 to 2. And then we're going to add up all the rectangles in terms of the y's, and that goes from 1 to 3. And that would be our equation. Of course, if you want to, you could switch these around. In this case, not in all cases, but because of our domain, it's just a rectangle, you can actually switch this from 1 to 3 and then from 1 to 2, and you'll get the same answer right there. All right. Let's see here. For number 38, for this one here, we want to find the area underneath this function. So we are in terms of x. So my rule is I'm going to keep a vertical rectangle. So between 2 and 3, we're looking for this area right in here. If I draw my vertical rectangle, the vertical rectangle tells me what the change in y's are. So I can get my limits pretty easy here. My change in y, well, that's going to start at the bottom, which was 0, and go all the way to the function 1 over the square root of x minus 1. So that's going to be my limits for my y. Now remember, we're going to slide this over between 2 and 3. So my change in x's is just going to go from 2 to 3. So let's see here. So now I can rewrite my equation here. Let's see here. So to get the area, I'll do my double integral. Now remember, because it's in vertical, it's in terms of x, this is going to be dy dx. Very important. It's going to be dy dx. So dy dx. So my y's are going to go from 0 to the square root of 1 over square root of x minus 1, and then from 2 to 3. And that would give us our area. Now remember, if you want to do it horizontally, that's going to be a lot harder to do. 1, you're going to have to split it, but 2, you'll have to use inverses right there. All right, go to the last video, and we're going to talk about how we can go from, what if I do want to switch, like from dx dy to dy dx. We're going to take a look at an example like that in our next video. I will see you then.